Hello, welcome back to yet another episode in CSC 280, the Introduction to Cybersecurity at the Delphi University. In this video, we continue our discussion about threat modeling. In the previous video, I introduced the concept of systems and system modeling, and we explored what data flow diagrams look like. Today, we'll continue to build on those data flow diagrams and see how they can be turned into a full threat model. I mentioned this before. There are many different ways and methods by which we can create threat models. Often, especially when it comes down to modeling, which is as much an art as it is in science, start simple. And only when you realize that you started too simple is it worth to expand complexity. But for the beginning, let's just stick with data flow diagrams and see how far we get. You'd be surprised how well they work. So when we do threat modeling based on DFDs, we have to go through a number of steps. The first step is to create the data flow diagrams, just as you would ordinarily create them in a non-threat modeling scenario. And we can use different models for different aspects of the system or different areas of the system, or maybe of different levels of abstraction. It doesn't really matter as long as the models are consistent and as long as they are comprehensible. Nobody is looking for a model that fills an entire wall, even though it might describe the system very well. It's hard to understand and to comprehend, and of course that is one of the main goals of creating a model in the first place, is to reduce simplicity. So as we create models and they start looking messy, that generally means that you need to do something different. A good model is often a model that looks clean and is not cluttered. Once we have created the data flow models of the systems that we are modeling, we're going to make sure that each of the elements of our model, so all terminals, all processes, all data flows, and all data stores have meaningful labels, and that those labels are correct. So for example, if I'm looking at a process, the label should express that we are doing something there. Assign grade, create order, all of those things. So we're trying to reflect what the process does in its naming. We want to make sure that that is clear. Once we've done that, it's time to start departing a little bit from the pure conceptual modeling approach, which would be completely technology agnostic, and start thinking about boundaries. In particular, where do we transfer data, so where do we see a data flow, that crosses over from one system into another system, or from one realm of control into another realm of control, or maybe from one trusted environment to a less trusted environment. Each of those signifies some form of a transition. By default, data flow diagrams do not have a notation for that. Data flow diagrams don't know anything about boundaries. That is an addition that we are going to make when we are threat modeling. And for now, let's just assume a boundary between systems is reflected as just a dotted line. Once we've critically considered all of our data flows and we've identified if these data flows happen within a system or between systems, or trust levels or zones, or however you choose to use as a foundation for your boundaries, it's time to move on to look critically at each of those transition points. Anytime that you have a data flow crossing a boundary, that is in a large extent where risk could manifest itself. Because at that point we're moving from one realm of control to a different realm of control. And in many cases that means that we are moving from areas that we do control to areas that we do not control. So those different trust levels. And each of those transition points we want to assess for potential risk. What's the worst that could happen here? And then we map that to what we actually have in place to see what our residual risks are. For each of those threats that we find, when we find those gaps, as in, well, this could happen and we did not address it appropriately, now we have to figure out what we're doing. And so that means that we have to make a risk management decision. And that risk management decision could be leave it as it is an acceptable risk. It could be, let's see what we can do to make it better, to reduce the risk. In other words, to reduce the likelihood of exploitation or to reduce the impact of exploitation. Or third, maybe we're going to transfer it somewhere else where we're going to say, well, listen, maybe we don't want to have a boundary here. Instead of building a system ourselves, we might purchase it. Or maybe the opposite, where we say instead of purchasing a system, we're going to build it ourselves so we have more control. All of those are options that need to be considered whenever you have a risk mitigation that needs to take place. And then, of course, once you've planned for it, you actually have to do it. It's nice to be doing all kinds of risk planning, but if you don't translate into action and into actual remediation of the problems that you encountered, you might as well not have done the exercise in the first place. That's the premise of model-based or threat model-based security management, where we're basically constantly trying to map out what our environment looks like for each of those trust issues that we identify. Well, what's the worst that could happen? And what did we put in place to make sure that the worst didn't happen? That should tell us what the gaps are. And then from that point on, we can determine a strategy to reduce risk and implement a reduction. Now, a model is never done. You create one and then you realize that you can simplify it or that you've missed something. So it is an iterative process, much like computer programming. The other part is that the environment in which our systems exist also constantly change, which means that the models, of course, have to always reflect reality, and that is a whole issue in its own right. But here is one of those examples. So, for example, on the top left we have a terminal called the user. The user is not part of our system, he is external to our system, and that means by definition that any interaction with that user is untrusted. Whatever the user tells us, we should take with a grain of salt and really fact check both the format of his input as well as the nature of the input. But also, just to be a good neighbor on the internet, everything we send back to that user we should do as well and make sure that we only put good content out of our system. So in this particular case, we have a model of a web application and specifically the authentication aspect of it. So for example, in the middle we have a process that says verify authentication credentials. So the input would be the login request containing those credentials from the user. And what gets sent back to the user is a decision whether or not we're going to trust them. That verify authentication credentials process relies on information obtained from a database. And in this case, the database is external to our systems, and therefore we don't trust the database, at least not fully. And that means we have a trust boundary there. Anything we send to the database needs to be carefully considered. Everything coming back from the database needs to be carefully considered. And so this threat model itself is fairly simple, where it identifies the point where we need to focus at least our initial security controls, and that is on the interaction with the end user and on the interaction with the database management system. Now, how do we then assess those threats? Well, we already looked at one. Stride gave us those aspects of things that could potentially go wrong, starting with spoofing and all the way down to elevation of privilege. There are other initiatives that you could use, but pick one and go with it, or maybe pick two and go with them. They probably have quite a bit of overlap, but each method might have a slightly different approach. Anyway, there are different methods and techniques out there for threat modeling. We explore some of those in a graduate class called threat analysis. But for now, let's stick with Stride. Again, it's fairly simple to understand, and it serves the purpose of illustrating our examples. Now, let's take an example then. Let's say that we identified the fact that, well, if a user is trying to authenticate, Stride tells us that they might be spoofing their identity. And that's bad. So how would a user spoof their identity? Well, we could say, well, they could steal someone's credentials and offer those credentials as their own. That's called stealing credentials. Or they could hijack someone's session. There are other ways that they could do it, but for now, let's dig in. Okay, how could they steal credentials? Well, they could steal credentials through social engineering. They could do it through stealing their passwords, all different ways. And then so each time we ask this question, how would we do that? And we refine the attack mechanism. In the end, we have a technique that is directly usable. By doing that, we create what's known as an attack tree, from the highest level of abstraction down to an actual attack. And these attack trees can be reused over time. So this is one fairly simple example that works surprisingly well. In the example again, let's say that I have building a web application that asks users to upload photos. The photos must be tagged with the approximate date and location at which they were taken. They should include a description of the subject. Users must register with the system after they will be able to search photos submitted by others and send messages to those other users. If I start creating my initial model, my initial data flow diagram, or in this case my initial use case diagram, I put the user in the middle and I put a bunch of processes around. And I can refine this model into more actionable ones. For example, based on this, I can create a level 0 DFD where I have the user who has processes to verify the credentials, to recover a password, or to supply their initial credentials. And all of that interaction with the user goes across trust boundaries, and as such, it should be subject to inspection. And so, as we start digging into these models and we start identifying where those trust boundaries are, we can start figuring out what could possibly go wrong, how do those attacks work, can we create attack trees, and then based on these attack trees, we can create models. So for example, we might say, well, my attack tree revealed that a user could request a password for someone else through a self-service password link. Now we could say, okay, well, if they do that, we're going to send them a password link, but we're going to send that password reset link to an address that we had previously on file for this user, so that even if someone else initiated that process, it would have to involve the actual user to complete it. So that would be a reduction of risk. I could say maybe, okay, if I know that, maybe I'm going to guess what that link would be. Okay, so we're going to randomly generate that link so you cannot guess it. Maybe we're going to receive all of a sudden a password link that we didn't expect. So what are we going to do there? So all of these things now follow from our threat models and our attack trees, and they allow us to identify controls. And that's how we design and build defensible systems. In class, we'll do a few more case studies to figure out how this fully works. That's it for now. We'll move on to the next topic in the next video.